Hello student, I welcome you all in online lecture series. I am Dr.Ganesh Mogal, Assistant Professor, Department of Physics, KTHM College, Nasik. We are discussing about the computational physics. In this lecture, we have to see numericals of Newton-Rapson method. So let's begin. Friends, in previous lecture, we discussed about the error in a computational. That is error in computation, that is inherent error, numerical error. We also discuss about what is a accuracy, what is a precision. In previous lecture, we also discuss iterative method, that is a bisection method to determine the root of equation. Friends, in this lecture, we have to see the numericals of a Newton-Rapson method. After attending this lecture, student will be able to find the root of equation by using Newton-Rapson method. So question is arises, what is the Newton-Rapson method? Newton-Rapson algorithm, this method is the most popular root finding method. This method is a name after Isaac Newton and Joseph Rapson. So that this method is known as a Newton-Rapson method because this method is discovered by the scientist Isaac Newton and Joseph Rapson. It is used to find the root of a given function. The Newton-Rapson method is a better approximation method as compared to some other numerical method. It is based on the idea of a simple linear approximation. This is a one point method since it required only one starting value and does not need to satisfy any other serious condition. So it required the first approximation or initial value. Here this represent a function fx. Okay, now here if the approximation x0 is given, okay, or we can say that this is an approximate root of a function fx. X0 is a approximate root of the function fx. Now x1 can be written as x0 plus h. Okay, this is the next root. X1 it is equal to x0 plus h. Here the initial root or initial value is given, that is x0 is given, or we can say that x1 is a given. Okay, now we can find or we can expand f of x1, it is equal to f of x0 plus h, and by using Taylor series this can be written as f of x0 plus h f dash of x0 plus h square divided by 2 factorial f double dash of x0, okay, plus the higher terms, it is equal to 0. But consider the higher term of this series is a very small and therefore neglecting all these terms, and hence we get f of x or f of x1, it is equal to f of x0 plus h f dash of x0. Okay, and from this we get here h is equal to minus f of x0 divided by f dash of a x0. This is a value of a h. Here f of x0 it is considered as a 0. So this term it is equal to 0 and therefore h is equal to minus f of x0 divided by f dash of a x0. And therefore we get that is x1 is equal to x0 plus h. So this can be written as x0 minus f of x0 divided by f dash of a x0. This is a first value we get here. Okay. Now we have to find the second root. Okay. That is x2. So x2 can be written as x2 is equal to x1 minus f of x1 divided by f dash of a x1. Similarly, we get x3. Here is a x3. Okay, this is a x2. This is a after first iteration. This is after second iteration. That is a value we obtain value of x3. x3 is equal to x2 minus f of x2 divided by f dash of a x2. This is after first iteration. This is after second iteration. This x4 is after fourth iteration, and after that we get exact root of this function. Okay, after that we get exact root. First is the initial Gauss, then after that we get x0, x1, then x2, x3, x4, and then exact root. Sometime there may be x5, x6, x7, the up to number of iteration given in a problem. Okay. Now find the smallest positive root of x cube minus 5x plus 3 is equal to 0 using Newton-Rapson method up to 4 iteration. So here function is given and function fx it is equal to x cube minus 5x plus 3 and it is equal to 0. Okay. Now f dash of x it is equal to d dx of x cube minus 5x plus 3 it is equal to 0. Okay, or and this is 3x square minus 5. Okay, this is a f dash of a x. Now f double dash of a x is it is equal to 6x. Okay, when we put value of x as a 0 we get f of x f of 0 it is equal to 0 cube minus 0, 5 into 0 that is a 0 plus 3 plus 3. So it is equal to, now f of 1, it is equal to 1 cube minus 5 into 1 plus 3. So it is equal to minus 1. Here value of f of 0 is a positive and value of f of 1 is a negative, and therefore we can say that f of 0 into f of 1, it is less than, less than 0. Hence root is a lies in between 0 and 1. Root is lies in between 0 and 1 because f of 0 into f of 1, it is less than 0. Now if we consider f of x0 into f double dash of x0, then it is greater than 0. It is a greater than 0. Now find f double dash of a 0. When we put value of x as a 0 in f double dash of a 0, it is 0. Okay. Now f double dash of 1, it is 6 into 1, so it is a 6. Here f double dash of a 1, 6 into 1, it is 6. Okay. Now f of 0 into f double dash of a 0, it is 3 into 0, so it is equal to 0. F of 1 into f double dash of a 1, so it is equal to minus 1 into 6, it is equal to minus 6. Okay, minus 6. So here for this we can say that this value is a 0 and this value is a negative. Okay, so we can say that thus both 0 and 1 does not satisfy the condition of the equation. Hence we try for another value in between 0 to 1. So consider the value of x0 in between 0 to 1 as 0.3. Okay. So this is approximate root we consider here. Okay, 0.3. Okay, now f of 0.3 into f double dash of a 0.3, it is 1.527 into 1.8, it is greater than 0. Okay, so that here we consider this is the first approximation. Now iteration number 1, we have to find the root up to iteration 4. So iteration 1. Okay. Iteration 1 can be represented as x1, it is equal to x0 minus f of x0 divided by f dash of a x0. Okay. So x1, it is equal to value of x0 is a 0.3 minus f of x0 means f of 0.3 divided by f dash of 0. So this is equal to 0.3 minus 1.527. This is f of 0.3 minus 4.73. This is f dash of a 0.3. So after solving this, we get value of x1 is 0.622833. Okay. Now we have to find second iteration. Iteration second. So iteration second, it can be represented as x2, it is equal to x1 minus f of x1 divided by f dash of a x1. So it is equal to value of x1 is a 0.62283 minus f of x1. When we put a value of x1 as a 0.622833 in the function, then we get the value f of x1 is 0.127445 divided by minus 3.836237. When we put the value of x1 in f dash of x, okay, that is a 0.622833 in a f dash of x, then we here we get 0.65604. After solving this equation, we get value of x2 as a 0.656054. Okay. Now third iteration. Iteration third. Iteration Iteration third, that is x3, it is equal to x2 minus f of x2 divided by f dash of a x2. Very simple. Okay. So x2 is 0.656054 6054 minus minus when we put value of x2 in our function given function, then we get f of x2 as a 0.002099 and f dash of x2 is minus 3.708778. Okay, after solving this we get this value of x3 as 0.656620. Now we have to find fourth iteration. Iteration 4. So x4, it is equal to x3 minus f of x3 divided by f dash of x3. So value of x3 is a 0.656620. Now put value of x3 in a given function, so we get f of x3 as 0.000001 divided by f dash of x3 is a minus 3.706549. Okay. And after solving this we get value of x4 is 0.65662043. Okay, so here if we observe the value of x3, then it is a 0.656620. Value of x4 is 0.65662043. Okay, so these digits are same. Okay, if we consider the value of x2, then the 4 digit are same. Okay, or simply 3 digits are same, 656. If we consider the value of x3 and x4, the 6 digit after decimal points are same, and therefore this x4 is exact root of this given function. Okay, x4 is a exact root of the given function. Now you have some assignment. Find the smallest positive root, that is x cube minus 4x plus 1 is equal to 0 using Newton-Rapson method up to third iteration, and send this assignment on a Google Classroom. Okay. So friends, in this lecture we discuss Newton-Rapson method. What things should keep in mind First, sometime the initial approximation is given, but sometime it is not given. We have to find it. So x0 we have to find. Here, the next approximation x1 is equal to x0 plus h. H is equal to minus f of x0 divided by f dash of x0. And therefore x1 can be written as x0 minus f of x0 divided by f dash of x0. Okay. Similarly, we can find next approximate root or a second iteration by using formula x2 is equal to x1 minus f of x1 divided by f dash of x1. This is carried out up to which we get the proper root or exact root. Okay. After this lecture or in next lecture, we have to see algorithm, flowchart and C program to find the root of equation by using Newton-Rapson method. Thank you.